Hello everyone and welcome to yet another recreational programming session with Mr. Zozin. So today we're going to continue working on the B compiler, right? So B is a predecessor to C. This is the language that was before C, right? And we're trying to kind of recreate it. So it already come really long way. So while I was doing different things, a lot of people were submitting pull requests and stuff like that, implementing very cool things. So thanks all of the contributors who contributed cool things to the B compiler. So here they are: Yui915, Mick Mart, Null Nominal, so Karuro Chori and Abath, right? So you submitted only like, okay, but anyway, thank you so much, right? So I suppose at this point, half of the compiler is actually implemented by Yui, right? And it can do a lot of things, right? So it's already pretty usable. So let's take a look at it. So let's take a look at the compiler. I haven't looked at the compiler on the stream for quite some time, so there should be a lot of changes. Right, so yeah, I'm gonna do origin main, and if you take a look at how many changes was made, that's a lot of changes. Look at that, right? So that's quite a few changes. So now let's actually do make and rebuild the whole thing. Right, there we go. We got the compiler, and it doesn't look that different on the surface from anything, but we've got quite a few cool examples in here. Let me do clean up DX. Right, for instance, Yui as well implemented a whole game in B programming language. Right, so this is the entirety of the game, and it's a snake game. Right, so let's actually try to run it super quick. I'm gonna go in here and I'm going to try to simply compile the snake games, right? So it compiles very quickly, and then we can run it. So this is implemented in B. So if anyone curious, what can you do in this programming language? So this is what this language is capable now. And what's funny is that it also works on ARM, right? Remember how we added the ARM support and stuff like that? This also works on ARM. So yeah, it doesn't implement the entirety of the described features of the B language as it described in the reference, but it implements enough to do some cool stuff, right? So definitely check it out, right? Maybe if you find something interesting to implement, consider submitting pull requests, but keep in mind that it's kind of difficult to go through my code reviews. Because I have a very high standards. So anyway, we developed architecture that allows you to add relatively easily new targets, right? So as of right now, we have, I suppose, only 2 targets. All right, so if I take a look at the list of the targets, so this is the targets that we have, right? So x86-64 for Linux specifically, and as a backend, it uses FASM, flat assembler. So AArch64 for Linux, and as a backend, it uses GNU assembler. And also we have intermediate representation. So it doesn't really do anything particularly useful. It just dumps the intermediate representation that then gets lowered to one of these specific platforms. So one of the targets that I wanted to add is UXN, right? So, and UXN is sort of like this ecosystem, personal computing stack, right? So that we looked into in one of our previous streams. It's sort of like akin to 6502, but as a virtual machine. It's a very simple virtual machine, but there's a lot of cool different ROMs implemented for that virtual machine. So definitely check it out as well. Right, so I'm gonna put it in here, and yeah, I was thinking that I want to add it as a target for the B compiler, and one of our Discord server members actually went ahead and implemented that. Right, so, and here is the pull request that implements this entire thing, and it's a pretty heavy pull request, like 1,000 lines of code, which is kind of on par with other targets that we have in here, right? So if you take a look at some of the others, for example, the main one, FASM x86-64, well, I mean, it's not, okay, so it's actually way more than I expected. But the thing is, x86-64 is a 64-bit, target. This one is actually 16-bit. So, and it doesn't have a lot of like useful operations that x86-64 has, so you kind of have to emulate them. Some things require several operations, so maybe that's where was the entirety of the difficulty of implementing this entire thing. Right, so, and I decided to take a look at this entire thing, on the stream. Honestly, I was kind of planning to stream myself implementing the UXN target, but it's not like I can control what people are doing or what people are submitting. So yeah, so some people just go ahead and just implement it myself and stealing my entire content. So, but again, I can't really control that. So if you're going to be stealing my content, I'm going to make your pull request into content. How about that? I think it's fair. Right, so actually somebody tried to submit a new target before. A PR rejected. We're not going to reject PR, we're going to actually review. And it was a risk 5. And I rejected that specific PR because, again, like 2 weeks ago, I was thinking that I kind of want to make it myself because that's kind of the content that I want to make. But it looks like it's kind of futile, right? So fighting that is kind of futile. So maybe I should just allow people to contribute things that I would like to stream myself and just stream reviewing their pull request as a revenge, right? I think this is a good, actually, you know, trade-off, right? So I have a topic that I want to stream myself. You want to steal that topic from me? Go ahead, but keep in mind that I'm gonna make your pull request into content. How about that? So now you know, right? So every time you think to steal my content, I'm gonna turn you into content. I think that's fair. So we're gonna proceed like that. And because of that, I think I kind of wanna maybe try to revive this specific pull request with risk 5. I think that would be an interesting topic, actually, right? So because it was 2 weeks ago, and the compiler is already evolved beyond this pull request being mergeable. In fact, this pull request implements like a very small subset of the intermediate representation, right? So it's not a full implementation anymore. I'm thinking to make a stream where I recover this thing and try to adapt it to the current state of the code base. Right, I think that could be interesting. So even though this pull request is rejected, I'm considering to revive it at some point. We'll see. Anyway, so let's actually go back to the UXN pull request and try to maybe run it on our machine, right? So hopefully we don't get pwned by Deniska. Right, so let's fucking go. Maybe the first thing I need to do, I need to add your repo as a remote. So here it is. I need to actually, as far as I know, in my Git, I can just add your name like this automatically, and it will try to guess the URL of the remote, right? So the only thing you need to do, you just need to add the username, and it will automatically work. Okay. So we are sort of fetching the stuff. That's pretty cool. And in Deniska, okay, so here is the UXN. So I create the branch for this entire thing. And let me try to go ahead and try to rebuild it. Will it build on my machine? So, all right, it seems to be building, but... So, and here is UXN target, right? So in the source code, we have an entire folder, which is called CodeGen. Maybe I should rename it to targets or something like that, but I mean, CodeGen kind of works, which contains, you know, different code generators for different targets. And here's UXN. Here's UXN, and it's a pretty big one. It's almost 1,000 lines of code. And here are all of the UXN, sort of like opcodes, all of the UXN operations. All right, that's pretty cool. So, and if I remember correctly, Deniska also submitted a couple of examples, right? A couple of examples that kind of work for this kind of stuff. So what is that? Gitignore. I think I know what the fuck it's all about. So there is a like kind of a problem in here, right? So essentially, the compiler kind of pollutes the current folder when you're trying to compile things. So essentially, if I try to do something like this, and I just try to compile hello world, right? So here is hello world, and I compiled it. So what it did, it first created assembly in a current folder, then it created object file in a current folder, then it compiled it into executable. So it created 3 additional files. So it's kind of a similar situation as with C3, where C3 like vomits a lot of O files in the current folder, but it's not exactly the same situation. C3 straight up like vomits shit ton of object files. Here, each an individual file that the compiler, you know, vomits, like emits, it actually has its own specific purpose, and I, as a compiler developer, want to be able to see each individual stage of the compilation. So it sort of like saves each individual stage in here. So we start with the B file, then it gets converted to ASM, then it gets converted to O, and then it gets converted to executable. And I want to be able to sort of like see each individual stage to troubleshoot something, right? To troubleshoot something. I was thinking about, you know, maybe moving them to a temporary folder or something like that. But I also want to be able to have a feature where, for example, I take ASM file and I feed that ASM file to the B compiler, and it continues compilation from that specific phase. You know what I mean? So essentially just like, okay, I gave you ASM file, treat it as the ASM file that you generated from B, compile it to O, and link it with a final executable. So essentially, if I troubleshooting something, I can always go ahead and modify this assembly and recompile it as it was generated by the compiler itself. Right, so I wanted to implement something like that. And because of that, I'm not really sure how I want to approach that, right? So even though this kind of garbage is annoying, but at the same time, it kind of makes the compilation process open. It shows you everything that is going on under the hood and allows you to modify some of these things. So I'm still thinking what is the best here from the point of view of the UX. So, and because it vomits a lot of garbage, right? So it vomits a lot of garbage, but it's a useful garbage. It's a useful garbage. So I have a gitignore in here that, by the way, somebody submitted pull request for. So essentially what you can do, you can ignore all of the files, right? And then you can exclude, okay, don't ignore B files, right? Because sometimes it's kind of difficult to ignore, like for example, executables, they don't have any extensions, they don't have any patterns, right? So it's easier to just like, you know, ignore everything, but don't ignore this one. So this is what I did. So, and at some point, like if you want to quickly get rid of all of the garbage, you can do git clean fdx, and it just automatically cleans up everything that was not committed, that was not part of the repo, right? So that's why this gitignore is important. So, and I suppose Deniska added like examples that only work for UXCN, right? Which is understandable. UXCN is a different platform from what we support right now, because right now we support x86-64 and ARM, and both of them 64 bits. UXN or UXN, I don't know why I keep calling it UXN. UXN is 16-bit. So because of that, the size of the word is probably different. So the same code may not work there. So that's why he kind of put this stuff into a separate folder. But on top of that, maybe, oh, he also works with a screen. So he tries to print something on the screen. Okay, so, and essentially what he tried to do, if I understand correctly, is just he tries to ignore garbage within this UXN as well. To be fair, I don't really like this kind of approach, right? So, because it kind of becomes complicated, right? We have a similar situation with test, right? So test is just like basically things that test your compiler, right? Different programs that test different capabilities of the compiler. Right, so there's a lot of different things in here. So some of the things like describe some of the bugs that we had. We have a ternary operator, by the way, right? So this is a valid code that we are capable of compiling, by the way. So the B compiler come very long way. Seriously, it's capable of doing a lot, right? So you can basically use it for recreational programming at least. Right, so it's kind of cool. So we kind of have a similar situation. I just put this gitignore in here. So what I'm thinking is that maybe for UXN folder, we kind of have to do the same, right? What if, okay, let's actually go back to when we didn't have that specifically, right? And it's just like, let's copy this gitignore in here, right? Every time we have a folder with a bunch of Bs, let's just like always copy the same gitignore in there, so we don't have to make complicated gitignores, right? So this is a folder with Bs, right? Ignore everything, don't ignore B, and also don't ignore gitignore, right? So I'd prefer it to be like that, right? So I kind of like it a little bit better. Folder with a bunch of Bs, it's called B nest, right? So folder with a bunch of Bs. All right, so let's actually maybe go. Right, and it literally just straight up ignored this thing. Ooh. So if they're nested, it's not going to work then. Fuck. So I think I'm starting to understand why I did it like that. Okay, so let's actually not do that then. Right, okay, so git ignoring is kind of complicated, all right, so we're not going to beautify this kind of thing. Okay, so we got hello world, right, so here's the hello world. Let's actually try to maybe compile the hello world, right, so I'm going to try to recompile the compiler. So here's the compiler. Right, so let's take a look at the targets. Here is the target uxn, and let's try to do hello world, right? So here's hello world, and it generated the ROM, right? So the way uxn virtual machine works is that it takes these ROMs and just executes them as a program, right? So it's basically just a, you know, file with the bytecode. We can take a look at how it looks like, and here is the uxn bytecode, right? So, and now we need a way to run it somehow, right? So I don't remember if I have uxn like somewhere here. I do have uxn, right? So this is basically yeah, so this is where it is located. It's on source hut. I think that's what it's called, source hut. And we even have some modifications because we looked into this thing on the stream. Yeah, so I was trying to integrate it into the Lagrange. Right, let me actually try to fetch the changes in here. All right, so there's some changes, as you can see. So Arch, they're also actually having like different platforms and stuff like that. So origin main, right, so how many changes do we have in here? So that's quite a few changes. That's pretty cool. Okay, so how do I rebuild things? Is there, okay, so there's a build sh. If I run build sh, it's supposed to rebuild all of the things. Okay, so on top of building the virtual machine, the assembler, the disassembler, and so on and so forth, it also automatically runs the boot ROM, right? So here is the ROM, and it's a boot ROM, and it's sort of like a built-in operating system or something like that, where you, I suppose, can basically look through different ROMs and stuff like that. So there is a bin, right? So, and these are the executables that we'll need in here. So uxn assembly, you know, uxn emulator, and so on and so forth. We'll probably need uxn emulator to actually run this thing. Cute background, yeah. So the creators are also pretty cool artists. So I really recommend to check out their stuff. So where's the description? Definitely check out uxn. Project. It's insanely cool. It's also insanely cute. Again, one of the creators is very cool artist, so they created a lot of art for this specific project. So it's very cool. It's very cute. So okay, so we probably need uxn emu to run the compiler. So let me go to B. Right, so, and I'm gonna start with the following things. So third party uxn bin, uxn emu, right? So here's the uxn emu, and what I'm trying to do, third party, no, not third party, what I'm talking about, examples, uxn, and here is the ROM, right? And so I'm just trying to feed the ROM into the emulator, and I expect to see some sort of a hello. Okay, so here is the hello world, All right, that's very interesting. So it said hello world and then hello world, and then it opened the window. I suspect that opening a window is sort of like a uxn thing, right? And maybe you can actually, I think it's a uxn CLI, right? So uxn CLI is an emulator without the graphical support, right? So if you want to have only the console, just do that. Okay, so what else can we do in here? So uxn 0 hello world ROM, and as you can see, so it just printed hello world. All right, so let's actually take a look at this specific example. So what's up with hello world? So maybe I also going to enable simd. So here's where we start executing, and here we look at the external function lchar, and where do we get that specific function? Where exactly do we get it? So is that a built-in function? So it's literally hard-coded, isn't it? Right, so because I don't see anywhere, we're not linking with anything. In x86, 64, and Arch, usually we work with external functions that are defined in libc because we link with libc, but here we don't have any linking stage, so it must be hard-coded somewhere. Right, so lchar. Yeah, okay. So generate externals. Oh, this is so freaking cool. Wait a second. So the list of externals, like in the compiler, every time you put external within a function, we remember that external in a list, and when it comes to generating the final executable, so we get this list of externals and we just do something with them, right? So syntactically generate something specific for the assembler, for the target assembler and stuff like that. What you're doing in here is actually quite funny. You go through the list of these externals, and if it's one of the built-in externals, you literally generating implementation for that function. This is funny. And also in UXN itself, so it's self-contained. So apparently this target comes with its own standard library, right? And it's the code gen that is generating this standard library. Absolute chudging. So this is cool. I really like that. I really like that. Didn't expect it. So that's pretty clever. Oh yeah, it's almost like a built-in lchar. Yeah, built-in lchar. And maybe at some point we could implement lchar for the rest of the targets, right? So because I want to be able to have a universal code, right? The code that works, for example, for x86-64 and for UXN, right? So that would be kind of cool to have something universal in here. Right, at some point we can implement that. And I kind of vaguely remember that char was actually, in fact, a part of the standard library of B as described originally by Ken Thompson, right? So if we take a look at the README in here, so here it is. So there was a standard library in there. So every target implementation is different. Well, I mean, we have 3 of them so far, including UXN that I'm reviewing right now. So the x86-64 and ARM are very similar because they're for Linux. UXN is the first one that kind of differs dramatically from whatever we already support. So it was kind of difficult to fit it in there. So Spearman did a pretty cool job, right? So fitting this unusual target to, you know, something different. Right, so where is the standard library? So here it is. Here it is. So library functions, and I do remember there was a char, and what char does, it takes ith character from the string that is returned. I don't think there's a l char. The character is stored. Okay, I think I missed this one. I do remember char, but I don't remember l char. So if I understood correctly, apparently B has literally only 2 kinds of reads and writes. It's the word size read and write and byte size read and write, and byte size read and write are done through the standard library, through char and lchar. So kind of interesting, right? So there's nothing in between, and it makes it especially funny in the 64-bit platform, right? So where the word is huge, which is 8 bytes, so you can only read and write 8 bytes or only 1 byte. Right, so you can't do 32 bits, 16 bits, or anything like that, right? So it's only one or the entire word, which is fine, I guess, right? So if you need to do reads and writes that are not an entire word, you're probably doing a very specific bit-byte fuckery, and at that point, you probably want to do like 1 byte reads and writes anyways. So it's kind of interesting. So maybe that's fine. Maybe that's exactly what you want to do. All right, so what other things do you implement in here? UX, okay, so DI, oh, okay, so it's a device. I remember that DEI is sort of like a device read or whatever, right? So, and there's also a second one. So it's a device input. It stands for device input. Yeah, not diversity, whatever, it's device input. Device output. And device output 2, electric boogaloo. All right, so that's pretty cool. All right, that's the only thing you support in here. Okay, so let me see. Like, we probably need to implement char and lchar for x86-64 as well. We definitely need to do that, I think. Okay, so in here is the put char. It's a put str even. Right, so here is the string. You do put str, then lchar. you mutate the string. So the reason why you printed hello world and hello world is to demonstrate how you mutated a string in a mutable data section. So device input was banned in USA? The fuck? I can only use device output? How am I supposed to, like, I mean, like, I don't know how we're going to be working with, well, I suppose we're not going to be shipping our compiler to America, right? So because it's banned in there for whatever reason. But anyways, so yeah, so it's a put string. And UXN is rather interesting is that it works with devices, right? It works with devices, and devices are literally memory mapped in some sense. They kind of memory mapped. So look at that. Essentially, right, we iterate in the string, and we just writing string in that specific address. And as far as I know, it's a specific like device address, and devices are sort of addressed within a different space than the memory, right? So we're writing it into this thing, and it like basically prints the character one by one. So that's basically what's going on here, right? That's actually pretty cool. That's actually pretty cool. I really like that. Anyways, so let's take a look at some other things in here, right? So this is a more complicated example called, oh, this is already a graphical one. Damn, holy shit, you like, oh, so this is sort of like a sprite. Oh, it's a bee. Look at that. So is it a graphical application that is going to like display bee on a screen through the UXN emulation or something like that? Holy fuck, this is so cool. Okay, so let's fucking go. Let's just try to run that. B, right, so TUXN, examples, UXN02 screen. Okay, so let's take a look at how big this entire thing is, right? So yeah, 1.7 kilobytes, right? So it's rather big. So now I should be able to take a look at the third party UXN bin. We'll probably have to do emulator, and let's do the ROM. Let's do the ROM. Ooh. Oh my god, it's even animated. Look at that, it's a small bee. It's a small bee, holy shit. That's so fucking cool. Damn, this is such a fucking cool example. I really like that. Bee. Bee. So, and it's very small one, but it works. It actually works, right? So it's implemented in a B programming language. So I actually worked with UXN and their assembly, and it's kind of a little bit painful to do anything complicated in it. It's basically like programming directly in assembly. But I mean, if we have like B programming language in here, I think it might be doable. Right, so all of that stuff is kind of complicated, but all of that works. All of that works, so that's kind of cool. So let's take a look at the subs super quick. Thank you so much, Development. Yeah, 15 months of absolute trading. X4204 with the message hello, hello. Statch Dude, thank you so much for tier 1. FGLG, who took my name, thank you so much for the sub with the message oops, I was AWOL. I don't know what was that supposed to mean. A few months. What's to watch? Always a pleasure, Todding. Never lose your curiosity. Thank you. I'll never will. LJSF, thank you so much for the sub and the message hi. NP Exception, thank you so much for tier 3. Nah, you probably know the drill. Don't subscribe with tier 3. I don't get any money from that. Wow, a whole year done. A whole year, indeed. So Bipolar. Thank you so much for tier 1. Thank you. So anyways, that is very freaking cool. It kind of makes me want to implement something myself. You know what I'm saying? Like I want to implement something for UXN. Right, so this is actually super cool. All right, so but I wonder how do you deal with the run flag, right? So because what we have in a compiler is that you can just not only compile but run right away. So this is something that you can do. So how do you deal with that in a UXN target? So let's actually quickly see. So where is the, oh, you don't, okay. So you just don't. You just put it to do in here. Can we? What if we essentially just pass the ROM to you know, emu, uxn emu, and expect you to have uxn emu in the standard path? What if we just do that? I'm kind of curious if it's going to work, because this is so we already know how to work with CMDs nuts, and we can try to do that. What if I just literally put this thing in here, right, and in here I just do uxn emu, and I'm just putting the effective output path, right? So here is the effective output path, and I just pass it in here, right, like this. So, and after that, run cmd reset sync, right? And it just tries to run it. So let me give it a try. So I'm gonna rebuild the whole thing. All right. So build b run target uxn, and example uxn, so hello world, right? So let's actually give it a try. Well, I mean, it doesn't have to be ROM, it has to be just b. Okay, so the problem here is that I don't have uxn in my path at all. So the question is, how can I quickly install that? Maybe how can I quickly install that? So here's the bin, and I suppose, yeah, all of these things are self-contained, right? So all of them more or less self-contained. I can just basically copy them somewhere. Oh, well, I mean, this is an emulator, which depends on a lot of graphical stuffs because it needs to display and everything. So in UXN is actually like, it's capable of a lot of things, right? So it's like a multimedia virtual machine. It can display animations, as you probably saw. It can also play sounds and stuff like that. So you can develop games for this small, you know, virtual machine. So as far as I know, like, yeah, so there's even some games in here, if I'm not mistaken. So is there, so here's the projects. Here's different software, pictures. Oh yeah, so there's just pictures, library, examples. Yeah, so there is a GUI example. Demos, Amiga, Bunny Mark. Okay, this one looks interesting. So we can try to do something like third-party UXN bin, UXN ASM, right? So let's try to build Bunny Mark, right? So, and you probably have to also print the output path. So this is the ROM. Here it is. So we got the ROM. So by the way, so what it feels like to program in this specific language. So this is how it looks like. So the original UXN assembly looks like this. So if you want to write anything, you have to write in this language. So, and we now are capable of writing software for this specific platform using B programming language, which, I mean, depends on your taste. Might be a little bit easier, but this one just gives you more control over what you output, because B, being a higher level language, it probably produces a lot of bloat that you can avoid by programming in this kind of thing directly, because as far as I know, each individual instruction in here is like 2 bytes or something, right? So it directly translates to binary. You can even directly specify the kind of bytes it will put in there. Right, so it just gives you more control, but B is a higher level language, so it's a trade-off between convenience and, you know, and control, right? Between convenience and control. And by the way, here is the device output and device input, right? So this sort of like the intrinsics in here. But anyway, so here's the Bunny Mark, and then I can do UXN emulator, and I can emulate the Bunny Mark ROM, and yeah, so I can, so this is actually kind of cool. I can click, oh, fuck. And it just like spawns bunnies. And Bunny Mark, as far as I know, is a classical benchmark for graphics, right? So which spawns a lot of bunnies and they're hopping around and just doing different things. So this is what you can develop for this virtual machine. And we can now develop for this virtual machine in B, right? So with a little bit of a bloat, right? So it definitely generates like more bloat than if you would have generated like handwritten all of this assembly, but still, right? So this is what it's capable of. Plus it can do sounds as well, if I'm not mistaken. Bitrate benchmark, yeah, so the bitrate is probably fucked. Can we make 5,000 of them? Probably, I don't really know. Yeah, I really apologize for the bitrate. Right, and there's a lot of different things in here, right? So devices and examples and stuff like that. Definitely check out this project. Definitely check out. So its source code is actually located in here, right? So maybe I should also add it in the description. So here is the source code of this entire thing. Right. So the original website in here, it does contain links to download, but I recommend you to look into the source code and build it from the source code, because the source code just contains more different examples, right? More different examples, so it's a little bit better. So I'm going to put these two things in the description. All right, so what I want you to do, I want you to just add UXN binaries to my path, right? So I usually have this OPT folder. And so here's all of the third-party projects that I install for that specific user. So I suppose I'm going to put UXN in here, and I'm going to just put the binaries in there, the binaries that I compiled. So this is bin. Might as well just copy the entire bin. Yeah. So here's the bin. So the only thing I need to do in here is I need to add this folder to path. Right. I usually use the profile for this kind of stuff. So this is path. Right, so, and that is, it's kind of interesting. So this is that, and this is path, and this is home, right? So this is home, right? So we're gonna put it in here. I don't know why I did it like that originally. So this is the profile, bash rc, so I'm gonna put all of that stuff into bash rc as well. All right. So here's the UXN. So I need to actually restart everything in here. So I do have UXN, emulator and stuff like that. And if I go to B, right? So now I should be able to do the following thing: run UXN examples 02 screen B, and it works, right? So look at that, it generated ROM and then it automatically run it. So we can just basically assume that if you're compiling for UXN platform, right, you have UXN emo in your path, right? You have UXN emo in your path, right? So I think that's more convenient. So you can iterate on things, right? So let me also start Emacs from within in here. And let's actually see how easy or difficult it is to iterate on things if you have this kind of system. Right, so here's B, run T, UXN, 02 screen, B, right. So T, there we go. So it's red. Now, what if I want to change its color? How easy it is to do that? All right, I have no idea how easy or difficult it is to do that. So there's 00, 07I. So this is that. So you directly, so here is the logo, and you directly sort of modify each individual character in here. So you have 16 of them in here. Right, and the sprite is 8 characters, I suppose 8 by 8. Right, so in fact it is 8 by 8, and I suppose this is the thing that is responsible for the red color, but I'm not quite sure what exactly is going on in here. If only I could put a hex or octal escapes in a string, but I can't because STB selects it. Well, yeah, maybe. Oh, here is the RGB. I have no idea how this colors works. So this is a red, this is a G, and this is a B. So yeah, this is kind of difficult. So I don't know how to modify this thing either. Yeah. So it's kind of bizarre. I was thinking maybe I can just modify the color, but it's definitely not obvious. It is definitely not obvious how to do that. But one of the things I can do, I can make this entire thing maybe faster, right? So that's one thing I can do. And does it feel faster? What if I put 8 in here? Yeah, it feels faster, right, as you can see. So, and I can now adjust the speed and quickly iterate on this application. So that's actually kind of cool. That is actually kind of cool. So let me now revert these changes. and revert this kind of thing. So I'm gonna run it again, and it runs again. So that's pretty cool. It's pretty cool. So yesu. So let's do something like this. Implement run flag for UXN target, right? So this is the thing. And do we need to like, I don't know, document that somewhere? Maybe, right? So if I just don't have, well, I mean, I think it's not required to document, right? So essentially, if you're working with the UXN, you are aware that you need to have this tool chain, right? So you're kind of aware. If you don't have it in the path, the application is going to try to run it, and the error message maybe is going to tell you that you have to have it. So let's actually see. Let's actually see. So where's that? UXN bin, something like that. So this is the emulator, right? So let's actually try to do this kind of thing. Yeah, I need to go into the example UXN, right? So could not execute. Yeah, so this is one of the reasons why I print each and individual command, that the application is actually running, so you know what the application is trying to do. So it doesn't try to obscure what it's doing. And as you can see, it tries to run the UXN. And since you work with UXN, you probably know what it is. And then it says that it couldn't find UXN, right? So it will try to add it to the path, right? So it's sort of like an environmental storytelling in some sense. Anyway, let me actually push that into your repo if you allow. Okay, so thank you for allowing me to push things. So that is very, very cool. That is very, very cool. So these two examples are pretty cool. So is there anything else I would like to review in here? You didn't really add much, so this is just all of the standard stuff. You added the UXN, and yeah, the only stuff in here is just the code itself, right? So maybe I want to look into that, but so far, if I just like look briefly through all of that, it all kind of makes sense, right? So not looking into the details, just like overall, it kind of makes sense. Right, so you also have a bunch of to-dos in here, a bunch of to-dos for different situations. That's totally fine. We may take a look at the to-dos, right? So let's take a look at the to-dos code, gen UXN. So to-do. So what's that? Load args. Okay, so when you load in an args and there is something external, so when you try to load the external arg. So it's really a hack due to how currently both funcs and global vars are the same thing. Without that hack, when you reference a function in an expression, you get the first byte of its machine code, which probably isn't what you want, and UXN really likes its function pointers. Ooh, so I didn't know that UXN has some sort of function pointers. It seems like in B, a function's name should evaluate to its address, and you should be able to call any expression, but fixing that requires making changes to BRS and all existing codegen, which I don't feel like doing right now. Okay, so I do not fully understand what the fuck is going on here, but that's fine, that's fine. All right, so I suppose we should go ahead and try to merge this entire thing, right? So, because it does in fact looks okay to me. All right, and what we're gonna try to do, okay, so there is no conflict. We're gonna try to maybe write something for UXN target. Sounds interesting. Sounds Gucci. Sounds Tomaguchi, right? I think it's something cool to try, right? So maybe try to write some game of life yet again. I already wrote game of life. Maybe something else. That would be interesting. So anyway, looks good to me. Thank you. And I'm going to merge this entire thing. So we are officially have UXN target. We officially have UXN target. So let me go ahead and just fetch the latest thing, right? And also merge this entire stuff. All right. So I want to make a small break. I want to make a cup of tea. And after we make a break and I have a cup of tea, we're going to try to develop something in B for UXN. Sounds good, Tomaguchi? Let's go. We're back. So let's go ahead and just try to do something. I don't know. By the way, can we try to port maybe this hello world? Porting this specific hello world may require implementing printf. So But I'm not really sure. You know what I want to be able to do? I kind of want to be able to compile several files. So essentially, I can have a printf implementation in a separate file for UXN, right? In a separate file in UXN. And when I want to compile my program for UXN, I just supply that additional file, right? And it uses that function as an external one. But unfortunately, we do not support multiple files right now. So as far as I know, we even have a to-do for that. There's a lot of to-dos in here. Look at that. Right. So support compiling several files. Support compiling several files. Maybe before trying to write anything for UXN, we can go ahead and try to implement that specific feature. Support several files. Unfortunately, supporting several files is kind of annoying, right? Because we recently added the following feature. Right, essentially, here I have an example, for example, sequence, right? So sequence program, and it's kind of similar to sequence from POSIX, right? So you have this kind of thing, you can do seq10, and it generates you a sequence of 10 numbers, and you can use that in bash scripts and so on and so forth. I re-implemented that in B, right? So I can try to do something like this, and I try to compile the sequence, and then I can say, okay, run this entire thing. Run this entire thing, and as you can see, it says missing operand, and then I can do 10, right? So, and how did it know that here I supplied the file path, right, supplied the file path, and here I supplied the argument. So as far as I know, the way it is implemented, and it was implemented by Yui, and I approved that, by the way, so it's not Yui's fault, right? It's actually my fault because I don't know how to do that better as well, right? So the way he did that, the way he proposed is that if run is enabled, it also looks whether input was already provided, right? If input was already provided, everything after that that is not a flag is interpreted as an argument, right? So yeah, but now if you add, if you're gonna add support for multiple files, how you gonna do that actually? Right? So because like how are you gonna distinguish from input files and the command line arguments for the run? So dash dash is a convention. I do agree with that, but we are using not really third-party dependency, but we are using a library for parsing command line flags, right? And it does in fact support dash dash. So what it does, it stops parsing when it encounters dash dash. That's what it does. It stops parsing when it encounters dash dash. So, and essentially this is how we do. We parse arguments in a loop. We try to parse them, and essentially, if it stopped parsing and you still have arguments, that just means that it encountered something that is not a flag, or it encountered dash dash. So that's what it did. It encountered that dash. And in that case, so if it's a file, you add it to the files and so on and so forth. And you can try and again, in case you have more files. So this is needed for the situations when you have a B compiler, you have some flags, right? You have a file and you have more flags. You know what I mean? Right. So essentially the library will stop parsing as soon as it encounters flag or dash dash, right? So it stops. You process the files, you try to parse it again, and then it stops, right? So it allows you to mix up files and flags. It allows you to mix up files and flags. So, but unfortunately, it doesn't know whether it encountered something that is not a flag or whether it encountered dash dash. And maybe that's a solution. What if we just basically expose that information? If the parsing stopped, we can just somehow through the API, through additional function, tell the user of the library, was it because of dash dash or was it because of something else? Right, so and in here, if it stopped in here, and it was dash dash, we can stop the entire parsing and just interpret the rest of the thing as the arguments for the run command or something. What do you guys think? Is that a good solution? So the problem here is that the library doesn't tell you whether it encountered dash dash or didn't encounter dash dash and just encountered something that is just not a flag. You know what I mean? We can take a look at the source code of the library. By the way, it's completely open source. So we have something dash dash. Where is it? Yeah, there we go. So here it is. Here's the main loop that is doing the parsing, right? So we take in the args. Is it a dash? Right. So it is in fact a dash. Oh, if it's not a dash, look at that. It's not a dash. We stop the parsing, right? But we consume that. If it's dash dash. No, if it's a terminator, we don't need to push it back. So that's very interesting. And in this specific case, we just return true, simply indicating that no error has happened. So encountering something that is not a flag and doesn't start with dash is not an error. It is not an error. So here, but it's a terminator, we don't need to push it back. Wait, if you encounter dash dash, it still stays on, so we still can inspect it. Is that what it is? Wait a freaking second. So I didn't realize that. So I need some sort of like a test example in here. I need some sort of a test. So that means I can just look at the argv and argc, and if it's dash dash, oh, so it already tells me enough information. I didn't realize that. So, okay, so if we encounter this kind of thing, what I can do, I can just iterate, right, through argc and just print the rest of the things, right? So we can do print f. So this is c, and this is going to be s, new line, argv, and we can actually add I, right? So because it has to be I, so we add an I, so this is a string, and after that we're gonna abort, right? So we're gonna abort this entire thing. All right, so I can try to rebuild the whole thing. Unreachable exception. This is annoying. So found. So I have to do as u32. So unreachable, it's an error, right? So in case of unreachable, this is error. No, this is not an error, but this one has to be I. Oh, this one, expected use size as use size. Yeah, so because argc is I32, so and it needs here use size in here. Okay, so that's understandable. All right, so this is a little bit annoying. So there's some unreachable code, but this is not a hard error. All right, so that means in here I can just try to do something like b. So a bunch of flags. So test foo bar. Oof. Yikes, 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 yikes. What the fuck is that? Excuse me. So I probably have to dereference this thing afterwards. So let's try to rebuild this entire thing. And it, okay, so it encountered test and then it did all of these things. So what I can try to do, I can try to put t in here, right? And it has to be, yeah. So t consumed test and it stopped in here. T consumed test and it stopped in here. So the rest of the arguments is foo bar. So maybe I'm also gonna say something printf rest of args like so. This is the new line. And in here I can put indentation so we know exactly what's going on. Okay, so rest of arg. So the test got consumed. So now I can maybe do the test a couple of times, right? And it gets, all of the tests get consumed. If I put dash dash in here, dash dash is also consumed, right? So we can't tell between dash dash and not dash dash. But not consuming it would have been actually kind of cool, honestly. It would have been kind of cool to tell the user that, well, yeah. So if you encounter this thing, yeah, so if you encounter not a flag, you're pushing back. We can do this kind of thing, or that. See what I mean? So now, if I try to rebuild, and it will rebuild the whole thing, now it includes dash dash, right? So as you can see, it includes dash dash. If I remove dash dash, it doesn't include dash dash. This would have been an ideal solution in my opinion. This would have been an ideal solution, but it introduced backward incompatibility. Like, because the API didn't do that before, now it does that. So the code that uses this function is gonna get broken, right? But we are modifying a local copy of flag.h. So for us, it is fine as long as we don't try to contribute it back to the sorting flag.h, right? So I can actually keep this modification, but I can't contribute it back to the original flag.h. So I'll have to think about that. So I can basically add this change specifically for the compiler, but then I'll have to think. How to contribute it back to the flag that is used by other people, right? So I can't contribute it to the upstream flag.h. So that's the tragedy of the situation, if you know what I mean. That's the tragedy. But this is something that is needed. Flag version 2, like I'm not sure. Maybe some sort of a flag in here additional, like a boolean or whatever, or I don't know. Right. So I'll need to think about that. So okay. What do we have in here? So we already kind of did this kind of stuff with stblexa. So let me see. So we have stblexa, right? So stb.h, right? So, and it originally was taken from this specific commit, but then we already added a bunch of custom changes in here, as you can see, right? Oh. So it's probably Yui who recently added that. I don't remember that. Did I not properly review that? So if I git blame, show me. Yeah, it's you who did that, and it's probably for fixing. Yeah, it's probably for fixing compilation with some other stuff. But I mean, it's fine, right? So we have custom changes. So we can actually do a similar thing for flag.h, right? So originally taken from, and I can specify the commit where we're taking it from, so it's that commit, if I'm not mistaken. So let me go back. So flag.h, and I want to have this thing. Changes, custom changes. Do not push back the dash dash in flag parse. So, and here is the to do think how to contribute this change back to the upstream without breaking backward compatibility, right? So something like that. All right, so, and this is, by the way, an advantage of owning third-party dependencies, because you can solve your problem immediately, right? You don't have to wait until it goes to upstream and get it back. You vendor your changes, you vendor your dependencies, you can just modify them. So, and this is actually kind of cool, right? This is actually super cool. All right, so if it's greater than 0, right, so we're looking what's going on in here. So here's the input path. We set in the input path. So if we already set a run, we just do that. So essentially what we have to do in here, in fact, we have to take a look at argv itself. If argv itself, strcmp, is equal to dash dash, this is where we have to stop the everything and consider the rest of the arguments, the run arguments. So that's what we have to do. This reminds me of patch package. Well, what this reminds me of is how I worked in a company that actually vendored its own Qt or Qt6 or like this library. So we did a product that depended on Qt, but waiting for changes to get upstream is a huge pain in the ass. So we actually had like our own copy that is heavily patched. And we had like a long list of patches. Some of the patches were waiting to get merged into upstream, but some of the patches were actually very much custom and could not be actually pushed upstream. So, and every time we had to update the version of Qt, it was a huge pain in the ass. Somebody had to spend like almost a week right, basically backporting all of these patches to the newer version, and we had a dedicated person who's been doing that. So this is what it reminds me of. Week seems fast. Well, I mean, we had a lot of competent people, right? So the person who's been responsible for that, he was competent, so he knew what he's doing. It's a pretty churn work, yeah, but that's totally understandable. By the way, this is something that I think one of the documents in the Linux kernel is talking about. Like in the Linux kernel, there's different documents that describe different things about contribution and stuff like that. And they were talking literally about this kind of thing. And they said that they encourage you to like submit upstream as much as possible, so you don't have to maintain this kind of shit, right? So yeah, imagine that your product depends on Linux kernel, and then you have like a long stream of custom patches, right? And if you don't push them upstream, that thing is going to grow like a cancer tumor, and it's going to be bane of your existence, right? So because the kernel changes all the time, based on external devs, yeah. So, and it's a lot of, honestly, what it reminds me of? Blockchain. Isn't that? Holy shit. That's literally how blockchain protects itself from, how to say that? From being not violated. What's the word? Proof of code. Yeah, it's kind of like a proof of work. Right. So, because if you try to do a fraudulent transaction, you have to do a lot of fraudulent blocks in the blockchain, and it gets harder and harder and harder, right? So, and if you don't submit your code changes upstream, it becomes harder and harder and harder to maintain them because it all diverges so much, right? But if you manage to put them upstream, it's going to be a responsibility of the Linux developers to keep your changes updated, otherwise the project is not going to build. So it kind of reminds me of that, but I'm not sure if maybe it's a stretch. Right. So that works because the Linux devs are not anal about changes that are not perfect. This does not work for other projects. Yeah, that's understandable. Anyways, so if we have like dash, so what we have to do, we have to start pushing them into the run arguments, right? Do I have something like a da append many? I do not quite remember. So da append. So da append is not here. So I think it was in here, di append. All right, so we have di append, and I also have di append many. So I can use that to push everything into the run argument. So here's the run args, di append, and here is the funny part. Di append many requires a slice, right? So it literally accepts the slice. So that means I need to construct a slice out of the arguments somehow. So let me see how I can do that. So slice. So I think it was in crust where I had the slice thingy. Damn. I remember there was a code from row parts. Yes. This one. So this is the code I needed. So what I want to do now, I want to take argv and then argc. But it contains dash. So what I probably want to do, so this is argc by the way, probably want to add 1 in here, right? So I'm adding 1, and in here I'm subtracting 1. So, and that creates a slice, hopefully, which I can push in here, and that will push all of these things into run args. And after that, we can probably safely break out of this entire loop, right? So maybe we can also say the name of this loop, let's call it something like args. And let's break out of args specifically. All right, so that's pretty cool. Now, if this was not dash dash, if this was not dash dash, what we have to probably do, we have to push that into array of input paths. And that's a very interesting thing. So now input paths is not a single thing anymore. It's an array of input paths. It's an array of all of the files that you have to compile. Right. So that's what it is. To be fair, I should have called it paths to indicate that it's several of them and to break all of the code that uses the original path. Right. It's very important to break all of the code because we're going to go into compilation errors and stuff like that. So we don't really care if it's null or not. So in fact, what we're just doing is we're just appending this thing there. So do I append mutable input paths like that, and we just appended this entire thing there. And in fact, all of that goes away. So adding support for all of that just makes it so much easier. All right, so let's actually go through the compilation errors. Let's go through the compilation errors. Make B. What do we have? Okay, so this one is easy. So input paths count is equal to 0, right? So instead of checking for null, we're now checking whether the array is empty or not. That's understandable. Okay, what else do we have in here? So read entire file input paths. Okay, so we have a whole process that just processes one file. Guess what we have to do now? Now we have to take the entire compilation here and put it into loop. So we have to iterate each individual file, right? And compile each individual file. In fact, so here is the compile program, and here is the state of the compiler that is zeroed. What we have to do instead of that, on the next file, we should not reset the compiler, but basically continue from a new file. So that will act like all of the files that you provided in there, they're concatenated together. Right, so in fact, you're not compiling several files, you're just compiling a single big file that is kind of concatenated. Right, so each next file continues the compilation. Right, each next file continues the compilation, so that's how it works. So because of that, I think the compiler should go somewhere here, right? So we also have CMD, which is kind of weird because it's not even used for the compilation, it's used for the code generation. Right, so it's a CMD and the output. All right, so that's pretty cool. So we do the target, the name here is the input. For each input we're reading it. So what we have to do, we have to do for I in 0 to input paths, several of them count, all right? And we're wrapping around this whole thing. And now the input path is input paths, items add I. So that's what it is. Do we have to dereference it? Yeah, I think we do have to dereference it. After that, we're taking the string builder. We're reading it. We're actually reading it, and then we're parsing it, and then we continue compiling and stuff like that. So that effectively means, by the way, that we're leaking a memory with the input, right? But I feel like we don't really... Do we store... Okay, so we have a notion of allocation, by the way. We have a notion of allocation. And allocation as of right now is an input path, right, so the file path, where the thing is located, input start. And input start is the pointer to the beginning of the buffer where the file is read. So relative to that, we can compute the line and column and stuff like that. So what I was thinking is to put input here, and then before reading, just reset the input so it reuses the memory that it got allocated. But that just means that after each reset, this input start is going to get invalidated. So we can't do that. So that means we have to preserve all of the files that we read and keep them in memory because we're going to use them for location calculation. But this is because the location calculation in STB selector is shit, right? So because it doesn't maintain locations properly. If it was maintained location properly, we could have just parsed and compiled file and fully forget its data, right? And only maintain locations as just like numbers, line, column, and file path. And maybe eventually we'll get to that. But as of right now, we can't do that. And the only solution here is to just leak the memory, I suppose. Right, so for each file, we're kind of reading the file and we're leaking it, but we still maintain the pointer to the file buffer in the locations in here for the start and stuff like that. STB B Lexa, yeah, so in fact, we have a to-do to eventually hack STB C Lexa into STB B Lexa, because there's the differences between lexical analysis of C and B. Right. So, and I feel like I need to probably put it to do in here. Right. So to do leaking memory on each file read. This is needed to not invalidate, you know, input start in struct lock. If stb c lexer.h just allowed us to have locations, not really locations, but let me, so stb selector.h, stb, so there was a location structure, so there was a get location. The structure is called stb lex location. If stb selector.h just allows us to have to calculate stb locations on the fly without calling to the slow get location function, so we would not need to maintain input start in the logs, and we could simply you know, reset the input string builder on each iteration, something like that. Right, so I think it's kind of important to mention that, because as soon as we have a better Lexa that doesn't require us to keep like a pointer to the buffer or anything like that, we can actually get rid of this memory leak. Right, so we can actually get rid of this memory leak. So anyways, so another thing in here is the string store. A string store, I think it is reusable, right? Because every time we encounter a string or identifier, we actually str dupe it into a local arena, right? We str dupe it into a local arena, so it's totally fine. So we're gonna keep it in here, and we can like keep reusing it for each individual thing in here. So okay, so we're reading the file, we constructing a Lexa out of this file, and we compile a program out of this Lexa and the input into the compiler. And now look, then we go on the next iteration, we read the next file, and we continue compilation from the next file. So this allows us to have several file compilation very easily, relatively easily. So, and I honestly feel like that is it basically. So let's actually see. So we need to go to the compilation errors and stuff like that. But so, okay, input path. Fuck. How the fuck do we compute the input path? All right, so we can actually do that on the first element of input path. All right, so we can do that on the first element of input path. In fact, yeah, so we can take input paths, just items, and just dereference that, right? So because it's the first element. I think that's fair, right? So if you didn't provide any files, it's not gonna even get there. But if you did provide some files, let's just use the first one as the, you know, as the base for the output path, right? I think that's fair. All right, let's fucking go. So input paths, items, like so. I think target won't survive that without changes. Okay, I don't know what you're talking about. But anyways, so here's the input paths, items, that, and right. So what else do we have? Input paths, items, that. All right. So yeah, there's quite a few places where we have to do this kind of thing, but I mean, that's understandable. Ooh, what is that? What am I even looking at? Huh. Alright, so let's do input path. Let input path like so. What else do we have in here? So this is IR, so input path items. Let's do it like that. Ooh, this kind of similar. Input path, so I can see where you copy pasted that from. What else do we have in here? argc -1, so it doesn't like argc -1 because it's I32 and it has to be use size. Understandable? Totally understandable. Okay, so as use size, sure. What else do we have? Slice, type differs in mutability. So yeah, it has to be immutable, that's understandable. What else do we have in here? So mismatch differs in mutability. Okay. Append many. It's because it's the internal one that differs in mutability because of the argv. Why are we actually... Can you just make an internal wall as const? Because I don't plan to modify it. So I can also have to make it as const. Alright, so what else do we have in here? Flag parse. Differs in... Okay, so... Freaking Rust. Why can't you just let me write code like normally? Why does it have to be always mutability and constant and shit like that? I don't fucking know. Shaving the yak, shaving the sorry. Let's actually try to approach that slightly differently. So this one is obviously mute. Add moment. What do you mean by that? I'm not sure. So this one has to be mutability and then yeah. Di append many. And the problem with the I append many specifically is that where is the menu? It accepts constant here, but sometimes you just have mute. Can't you simply accept as mute or as constant here? Can't you just like, you have mute, just treat it as const? Is always silent to behold. Yeah, I know. Well, I mean, it has to be something like mute char, right? That's what it wants. Maybe, oh, I think I'm being an idiot, chat. I think I'm an idiot. Everything's fine, actually. Input paths themselves have to be mute. I'm looking at the wrong place, in fact. Where are input paths? These things should be mute, right? So this is what I'm looking for. Because I saw const and I just like literally copy-pasted whatever was nearby. So that's the problem in here. Types differ in mutability. Well, yeah, and this one has to be something like that. Yeah, this one has to be mutable. Bro, can you... Let's try to understand what it wants. So this is mutable. So expected row pointer const, but this is not... wait a freaking second. Run R... this one has to be like this. Okay, all of them have to be mute. Finally. That was... Okay, that was harder than expected. It wants mutable but good mutable, yeah, whatever. So I think we finally make it compile. Absolute shredding. So even Crust manages to still stay annoying. It's anyways. So let me try to do some example that actually demonstrate how all of that works. First of all, let's actually do test Right, so do the test work? The test seems to be working, right? So we don't really have assertion or validation of the test results, but usually what I do right now is that I just run all of the tests and just like briefly look whether they make sense or not, because I know how they're supposed to work, so it kind of makes sense for me. In the future, I'm thinking that we're either gonna have an approach, something similar to ReaReaPy, right? To this kind of thing. So basically universal behavioral testing tool in Python. So it allows you to record and replay a behavior of certain programs, right? So we either going to use that or something null nominal submitted recently, right? So null nominal submitted recently as a PR. I briefly looked into that, but I haven't reviewed it yet, right? So I'll look into what you actually submitted, but I kind of have like a similar project that does a similar thing, right? So we'll see how to integrate all of that. So here's the description, and yeah, I'm gonna actually put it in here. So this one is actually a pretty cool project, right? So it allows you to basically just have a list of things. So we even have a project where I use that. So I don't remember. Did I leave a link in the project where I used uses? No, I don't remember. Where did I use that? I forgot. But I used it somewhere in one of the projects. So, and it allows you just to have, oh, I used it in Tula. I just like randomly remembered. Thank you, the universe, for reminding me. Yeah. So, and essentially you have like a test.list, and it's simply list of bash commands. It's a list of bash commands. And what the tool does, it runs each individual command and look at its output. And then it compares the output to what's expected, right? So here is the file that actually stores what is expected from the output of each individual command. And that way you can have like a very quick and very basic behavioral testing. So you can just run a bunch of commands, see if their output you know, the same as you would expect, right? And if something differs and that is expected, you can record it again and say that the current behavior is the correct one, right? So, and it's currently used in Tula, which is kind of semi-abandoned project, right? I would say it's finished project, right? So it's used in here. And the format that I use in here is actually kind of cool. It's like a BI format, right? So it's a binary format that looks like text if you store text in the binary blobs. All right, so anyways, let's actually continue. Let's see. All right, so all of that runs, everything seems to make sense, and I want to test all of that stuff on the sequence, right? So if I try to, yeah, so it rebuild everything. Now B, I want to run hello world, right? Just running hello world seems to be working. Okay, so now if I try to run the sequence, right, missing operand, if I just put 10 in here, that doesn't work anymore. So what you're supposed to do, you're supposed to actually put dash in here, right? That's the first difference. And I think that needs to be documented somewhere, so because it might be a little bit confusing. We can try to put that into the usage. So here is the usage. So input s, right, something like that. You know, args, yeah, arguments. Maybe, wait a second. Run arguments, something like that. Run arguments. I think it makes sense. And by the way, this thing is also kind of optional, right? So you have options, you have inputs, you have that stuff, and run arguments. In fact, we can even probably describe this entire thing like so, right? So this is the better description of the signature. Options, inputs, options. Though you can kind of actually interleave all of these things. You can kind of interleave all of them, but I don't know. So it's kind of difficult to precisely describe. Then you have dash, and this is the run arguments. So options or inputs, we can figure it out later. So what I want you to do is to just document that this is how you run the run arguments. how you provide run arguments. Right, so this is how we're supposed to do that. Okay, so that seems to be working. And we also have echo commands. 03 echo. All right, and here I can actually provide several things. Full bar buzz. Right, and as you can see, it just like acts like a POSIX echo. If I put a bunch of spaces in here, it concatenates them together. Right. So yeah, we got some subs. Thank you so much. Rosie, probably 41 subscription. Thank you, thank you, thank you. Really appreciate that. Cool. So, and you joined from YouTube. It's kind of interesting. So Twitch actually in a very cool position for them, right? So they do very little work to promote their streamers. And if you want to grow your Twitch channel, you have to bring viewers from other places. But at the same time, it's kind of difficult to bring people from Twitch. Well, it's not actually that difficult to bring people from Twitch to other places. I can literally tell you something to subscribe him somewhere, and this is how I bring new viewers. I don't know. So it's actually usually the streams go from other places to Twitch and not the other way around. Anyways, YouTube is better for getting new viewers. Yeah, it is better for getting new viewers. My path was Twitter, YouTube, Twitch. Damn, people are discovering me from Twitter. That makes me sad. Dude, I don't want you to have first impression of me from Twitter. Am I big on Twitter? Anyway. So let's actually continue. Man, I hate Twitter. I freaking hate Twitter. Just like everyone, by the way. Okay, so everything seems to be working, right? So we have command line arguments and stuff like that. What I needed them for? Oh yeah, so I actually needed multi-file compilation. So let's actually do the following thing. So we have main B, right? So, and I have something like, let's say, foo and bar, right? I have functions foo and bar. And I can probably put foo and bar in here, like so. And in here, what I want to do, I want to printf and say foo, and this is a new line. And in here, we're going to have bar. Okay. So what if I try to now run this program, main.b? Right. So I'm in the wrong place, apparently. Oh, this is because yeah. So this is what I'm doing. Don't have printf, that's understandable. So this is because it's an external command, external function. Let's do simpc. Okay, so can I just save this and test that? So this is external function. Cool, that works. So funnily enough, it's actually very sensitive to the order of defining things. What if I put these functions in here? I think it won't compile because they're not defined yet. But if I understand correctly, I can just call them as external, foo bar, and it will be able to see them. So it's sort of like a form of a forward declaration. And FUSM, damn. FUSM being really annoying about that. So it doesn't allow you to forward declare things that easily. Unfortunately, it doesn't allow you to do that. But maybe JASM is better. I'm thinking to actually switch to GNU assembler for x86-64 as well. Because the cool thing about GNU assembly is that it doesn't require external declarations. Right, so here is the thing that FUSM requires you to do. It's very anal about that. It demands you to have this kind of thing. Yeah, so in the future, we're going to have a GASM, right? So here's the list of these things. And I want to literally introduce that, and at least additional one, without FUSM gas, right? So maybe we're gonna have FUSM and gas targets along for a little bit, just to see which one is more convenient. And I feel like at some point we're gonna get rid of FUSM. So our GASM, haha, very funny chat, very funny. But anyway, so yeah, that's a little bit annoying. And how can we fix that? So we need to somehow distinguish whether we already have functions or not have functions and stuff like that. So where is the function that, like, if not defined, right, so if not exists. So here is the function that we use to declare new externs. Right, so here is declare node externs. So we encounter extern, all right, and if it is in fact extern, we just declare it in the list of externs. But we have to not do that if one of the externs is a function that we provided in one of the files. How can we do that? Well, we do not necessarily have to do that on the level of compiler. We can do that on the level of the shed FASM targets, right? So we can do it on the level of the shed FASM target. So I honestly don't really understand why FASM is so anal about having these externs, right? Maybe because it's so simple and it needs additional information, but GAS doesn't require any of that stuff, so it's kind of annoying. So here is the generate externs, and here is the externals, and we don't want to do that if there's function like that. Funnily enough, we can actually maybe accept functions in here too. So here's the BRS. Where is the struct func? Okay, so a struct compiler, and here is the funcs. I might just provide the slice of C funcs. Just provide the slice of C funcs. So funcs, and it's a const of func. Essentially, the idea here is that if the current name, right, so we might also factor this into a name. If the name exists in a function, do not add this extern. Yeah. So how can we do that? We can do j in funcs, j in funcs, and this is len. And for this entire thing, it's basically funcs. We have to dereference this entire thing into j, and struct func. Here is the name. Here is the name. And if func name is equal to that name, and this is not how we compare strings in crust, by the way, it's strcmp equal to 0, we have to in fact continue outer loop, which is this one. So we're skipping. Maybe we can even do skip function. See? Something like that. Something like that. It's kind of a hack, but it might work for what we're trying to do in here. And it's only for specifically FASM. To be fair, the list of these externs can be actually generated by the code generators, right? So because what they can do, they can iterate through all of the functions, through all of the bodies of the functions, and see what kind of external arguments we're referring to, and just build that list themselves, right? So building the list of externs on the level of compiler is a little bit too much work. Right, so I think we should delegate that work to the code generators. It's the responsibility of the code generators to figure out all of the external symbols. So what the compiler will do, it will just like use external symbols. Right, so, but it's for later, it's for later. Maybe I'm gonna do it myself, but this is just like a thinking out loud. Anyways, so let's try to recompile this entire thing and go through the compilation errors, and as usual, make dash b, right, okay. That compiled first try, surprisingly, but anyway. So now if I try to compile the whole thing, it compiled. So yeah. So that's pretty cool. Absolute chaining. So I actually, it's support for declarations in FASM x86-64. What's funny is that in ARM, according to how GAS works, GNU assembly works, it should just work, right? So there should be no problem to do this kind of stuff. In fact, this looks like a pretty cool test to add to our thing. So let's go ahead and do that. So I'm gonna call this forward declaration, right? So I'm gonna move this entire thing, and this is gonna be Git. By the way, null nominal, right? So I know that you're annoyed by this garbage. You can always do git clean to get rid of this garbage, but be careful that it will remove the old files. All right, so the files that are not committed. I think I have to maybe stash this entire thing. Okay, so I just staged it, and if I understand correctly, I can do git clean fdx, and it just automatically removes all of that garbage. Right. So, and I know that it's kind of difficult to remember these flags, right? But it's Git. This is something that you have to do, right? I don't remember the meaning of these flags. This is just something that I've just memorized. But yeah, so essentially, every time I have too much garbage, I just do git clean and it goes away, right? And the gitignore just makes sure that it doesn't remove, you know, important stuff. But anyway. Git is more like shit, am I right? Very funny. So the interface of Git is pretty shitty. The idea behind Git is rather cool, right? So, but how it faces the user is kind of cringe, honestly. I always have 500 uncommitted files in a repo which I actually want to keep. Okay. Interesting. Mercurial is much better. Well, I mean, the market has decided, right? The invisible hand of the market has made a decision. It decided that we need to shed VCS with a shed interface. So everyone prized the market. Everyone prized the market. Almighty market has decided that we need to shed VCS. Anyways, so forward declare. Is the market in the room with you now? No, it's a free market. It does whatever it wants. It actually went out. So it's walking somewhere. It's having a walk. It's a free market. Nobody's keeping it, right? So it's free to do whatever the fuck it wants. Anyways, so let me actually put this kind of stuff into makefile. All right, so, and let's put it in here. So forward declare. I only now noticed that the files are sorted alphanumerically. Do you guys actually keep them sorted intentionally? I don't remember actually making them sorted. I actually copy-pasted them from the output of ls, and ls actually sorts them. Yeah, okay, so... anyway, so do I have to keep it sorted? B, C, D. Well, let's actually keep it sorted, right? Since we started to keep it sorted. A, B, C, D, E, F. Right, so... Okay. I didn't intentionally do that, honestly. Okay. Well, at least it was staged. Oops, yeah. Wait, so that is bizarre. I have it staged, but I accidentally deleted it. I think I can just copy paste it, test, forward declare B. Just put it like that. Like this, and then put like that. All right, so here is forward declare. This one, let's remove that. So this is the forward declare. And yeah, now I need to do some commits in here. Actually, I just realized that I have two separate commits. First one for multi-file support, and second one for forward declaration. I actually have to commit them separately, honestly. I think I only edit forward declaration in the code gen, so I should be able to just do something like that. And that's actually a normal thing. Okay, so let me try to do make test, right? Okay, so forward declaration works, right? So here we run forward declaration, everything was fine. So add support for forward declaration in FASM x86-64 Linux. There we go. So now here, this is a multi-file support, right? So this is a multi-file support. By the way, I should have actually included that as well. Implement multi-file compilation. Not yet, because I need to confirm. There is a reason, by the way, why I studied the forward declaration. By the way, there is a reason. The reason is, now, since I have this kind of thing, I can put these two files into a separate file. Right, so let's actually do something like stdlib. There we go. So it is in a separate standard library now. Look. So what I'm gonna do, b, and I'm trying to compile main.b, and it compiles but doesn't link. Look at that. It compiles but doesn't link. But now, if I provide the second file, it compiles. Because the functions that main.b uses, they are implemented in a second file. This is the kind of shit you can do now. Right. Which means now I can implement cross-platform hello world. We can have standard library for UXN. Isn't that cool? I think it's pretty cool. So first of all, let's actually do the multi-file compilation. Absolute trading, chat. I do agree with you. This is absolute trading. Thank you. Absolute trading indeed. Absolute trading. All right. So let's actually do a committee as usual. All right. So implement multi-file compilation. Right, and I'm gonna push that right into the repo. So, by the way, it may break some of the pull requests that people submit. No, not this one, but this one. That's totally fine. Don't try to fix it or don't worry about it. Right, so when I get to your pull request, I'll try to fix all of the problems myself. Right, so just submit your suggestion. I'll look into it and we can discuss it, and then we can work with it. Okay, so let me see. So how can we even do that? Let me do git client fdx. Cool. Let's look at the hello world. Be built out. I need to rebuild this entire thing one more time. One more time. So if I try to do b, here's the hello world, and I also can run it. That works. That's cool. Now, target UXN doesn't work. A known external printf cannot. So this is what you were talking about, Nisko, right? So we'll. Interesting. So yeah, we probably can hack this kind of thing. So first of all, let me try to bring some of this stuff from here. This is a good candidate for the printf implementation, right? So we can have something like uxnb, right? So let's put it in here and we can say it's a printf. Even though this is not a real printf, right? So it doesn't implement any printf features, but we just need to make hello world compile. Right, so we just need to make this specific hello world compile. So we can say in here, printf for uxn is not fully implemented. And by the way, my friend, we can actually put all of your intrinsics like uxn and del into this file. Can we do that? Can you like fully? Maybe not. I'm not really sure, right? So, but we can take a look. So code gen uxn del. Right, so because you have quite a lot of things in here, is it even possible to implement that in B, or does it have to be intrinsic like that? Or maybe we could implement inline assembly. Del is unimplementable, I see. Inline assembly. And it's different depending on the target. Okay, so I'm gonna put it to do in here. Some sort of what to do. Consider introducing inline assembly target specific inline assemblers, assembling and implementing all these intrinsics in it. Right, so this is not like a strict to do that we have to implement, but this is kind of like an idea, some sort of an idea. All right, so here we can actually implement a very similar hack that we implemented for fuzzing, can't we? So generate externs, and if you encounter a function, in fact, you literally even create like a name in here. So skip function. Ooh, this kind of thing allows you to define your own char and L char. So it gives a priority to the function. Look at that. So it gives a priority to the function. If you define a function, it will use your function. Is that a good idea? Might be. I don't know. So it's kind of funny. But yeah, anyway, so here we have to accept the funcs. So there's even an entire assembler in here. So funcs, so const func. So that's what we have to do. All right, let's try to compile this entire thing. Let's go in here, make B. All right, so, and this is the slice of funcs. All right, that seems to be compiled. Cool. Let's go into the examples and 0, 1, hello. Okay, unknown extern printf cannot link. That's understandable. Now I'm going to provide uxnb. That worked. It couldn't run, but that worked. So let's now go here somewhere. And I can copy paste this specific program and put run. Why uxn emo? I renamed it to test, you know, what happens when I don't have it in the path. I forgot about it, I'm sorry. So happens. So don't judge me. Okay. That can happen to anybody, all right? Anyways. Okay, and let's try to run it. Okay. Absolute cheating. So, and this works now with any target. So this specific example is literally cross-platform. I'm surprised it works. Well, I mean, yeah, it works. Because it literally uses your code that originally works, right? It literally uses your original code. So that's why it works. So this is a standard library. So that means you don't need to have this example in here. Look at that. You literally don't need to have this example. So you can only have screen. And in fact, for like, we can even abstract away rendering of B, and depending on the platform, we can just supply different things. So on x86-64, that thing can use now Raylib. On UXN, it can use UXN capabilities. Right, with multi-file compilation, in fact, you can now have abstractions, right? So you can have platform-dependent code, right? So for each platform, you can have a separate B file that implements a certain interface, and then cross-platform code that assumes some sort of interface. And depending on what platform you want to compile it for, you just supply it like corresponding additional file. Does it make sense? Right, so this is actually a very powerful feature. Like an ability to compile several files is really powerful, right? So we can now write cross-platform code. Yeah, this is actually kind of cool. So the question is where do we commit this file and how do we communicate to the user that if you want to like compile the hello world for UXN, you have to just add this additional file. How do we even communicate that to the user? How do we even communicate that to the user? I have a feeling, by the way, that maybe what we have to do is we have to introduce std folder, right? And move this thing in here. And in the future, we need to have some sort of a mechanism that automatically adds this file if you try to compile to UXN. And maybe for each individual target, we're going to have a file that adds additional functionality. Yeah, by the way, in B, you implement printf like that. This is even described in the reference written by Ken Thompson. So let's actually take a look. Printf. So there was an example. Yeah, there we go. So this is the official documentation, official reference documentation for printf, and they literally implement it like that. And by the way, pointers should allow you to do variadics like this. It should allow you to do variadics like this. In fact, I'm not really sure why it is implemented like that. Right, because I have a feeling, I mean, yeah, I do understand why it is implemented like that. Right, so I thought that maybe what you just have to do is that you just have args, auto args, and you take a pointer, and every time you want to get the next pointer, you just do plus plus. But this is not going to work. This is not going to work because the prologue of the function actually has to move all of the arguments out of the registers, because on x86-64 these things are on the registers. It needs to move them on a stack, and only then it will work, right? Only then it will work. Without knowing how many arguments you have in here, you can't move enough arguments onto the stack. So you kind of have to provide all of that stuff. So that's understandable. That's understandable. So, and by the way, printf for UXN probably will be implemented like this. Right, it probably will be implemented like this, but it's not right now. Anyways, so we need to communicate to the user somehow how to like use this file, because I'm not really sure, because what you have to do, right, so you have a UXN, right, so and essentially what you do is you're supposed to do build b run, obviously, then you do examples 0 0 hello world b, and very importantly you do std UXN b. So that's what you have to do to make the example work, if you actually want to do that. So is that a good way to document this? Undefined reference, yeah, so it has to be. Honestly, you can actually implement these functions for x86-64. Who said you can't implement that? Well, at least char is implementable, that's for sure. So, and you can have some sort of a layer that implements UXN specifically on x86-64, and maybe uses raylib to render things on the screen. There's so many possibilities now with multi-file compilation. This is actually kind of cool. Damn. I think we're moving in the right direction, by the way. I think we're really moving in the right direction. I really like what I'm seeing here. So this one has to be UXN, right? So, yeah. So when it prints hello world, and that's totally understandable. Yeah. So is that a good way? Like, So I need to think. So there should be some sort of a to-do. All right, I'm gonna keep it like that for now. I'm gonna keep it like that, and maybe in the future we come up with something better, right? So because it's kind of difficult to communicate to the user how all of that works. Right, the compiler supports UXN targets. Make sure you have UXN emu in your path if you want to use if you want to use run flag, so something like that. Make sure to always supply the yeah, I don't know what to say there in here. Okay, standard library for the UXN target. Standard for the UXN target. So I kind of like outlined the direction we have to go to, but I myself not really sure. Right, so if now we have the std folder with additional files for different targets and stuff like that, how do we distribute it? Do we distribute it with the B executable? How B executable searches for that std? So this is kind of the main problem, right? So with all of the compilers, you have a standard library. Yeah, so something like that, std, then add target like std. Yeah. So something like that. But again, I'm not 100% sure on the details, and that's why I leave it like that, right? So I outlined what I kind of expect in there, but I don't have enough information to make a good decision, honestly. All right, so yep, what we can do in here, by the way, so uxn, I also, didn't I delete? Ooh, yeah, so it literally, yeah, it recognized this as a renaming. So it recognized that I renamed Hello World to the standard library. Yeah, that's kind of funny. So it's just git, right? So it recognized that I renamed it like that, even though this is not what I did, but yeah, it decided that I did that. Okay, so let me now do something like this. Make examples 01 hello world fully cross-platform, supporting uxn. Yeah, so I'm gonna push that. Silly git, yeah, git is in fact silly sometimes, and even the word git kind of means silly, isn't it? Right, or is it more offensive word? I don't really know. It's from British English. I'm not that familiar with British. All right, so I'm already streaming for 2 hours, right, and 20 minutes. So I think we did a good job today. We reviewed the pull request, and we also extended the compiler to support new, cool, exciting things. So yeah, I guess that's it for today. Right, that was actually pretty cool. Thank you so much, Deniska, for this pull request. Thanks everyone for watching. I really appreciate it. Have a good one, and I see you all on the next recreation programming session with Ahu, Mr. Azuzin, as usual. I love you. Mwah.